All right, welcome to day 4 of my journey to being or becoming proficient at Web3 analytics with Flipside Crypto. So, continuing where we left off today, let's just get right into it. No need for introductions. So, we left off and we got to our next subject is the sum aggregation function. So, here we go. Let's move on from DEX swaps and look at NFTs and the Ethereum.core.easy NFTs table. Sum allows us to pass in a numeric column and total up all records over the result set. In this case, we are summing up the OpenSea platform fees in a token and USD amounts over the month of June. So here's the query right now. I'm going to copy it over here and let's paste it and see our results. So it should have all the platform fees and then the platform fees in USD. Okay. Okay, so we have around 12 million USD. This one says about 15 million, but we'll let that slide. A massive number for native token fees. Why is this? We should check the documentation table for the total platform fee column to see what we're working with here. Is there anything that leads us to question our data or change our approach? We may want to delve deeper into the data. We see from the documentation that the column is decimal adjusted, so that's not it. There's a hint in there, though. The words in the transaction currency. So a strong analytical process would lead us to checking what currencies are listed in OpenSea sales. So we're going to see all of the currencies now. That's what this will. So we'll do this. Oops. And we'll see all the distinct currencies in our OpenSea sales. So we have a bunch: DAI, Ape, Uniswap. There's a bunch of currencies, as you can see. So this one right here, select platform fee, it looks like it's going to just only do the ones that are in ETH. And 4. There is one more colon right there that will make it so it doesn't work. So now we have, this is an ETH, it looks like, and this is converted to USD. So the same thing with sum, you can do average, min, max, median. So those are just different mathematical functions that should work the same. It's an aggregate function just as sum. Little typo action there. Happens a lot. So you could see we have the median platform fee, the min, the max. Oh, 25 ETH for a platform fee. That is crazy. Someone got ripped off. All right, so that concludes the segment of the first one. And we're going to go on to segment 2. SQL aggregated. We can calculate some stats and metrics across our result set, but we often want to see what's happening within the set. both over time and across groups. Enter group by. Let's build on the code we used in segment 1, specifically the OpenSea sales. In that example, we just used where currency equals ETH, and we got most of the sales for June. But we don't want most because that's a bit too convenient of an approach. So instead of excluding everything and just filtering to ETH, we can use the group by to sum within groups. So this one right here, we're selecting the currency, all the platform fees, and we're grouping each fee, the sum, by the total of each currency symbol. Let's not order by the currency symbol. Let's order by platform fees USD. So we could see which ones have the most. So obviously ETH, then wrapped ETH, then Gala. People will be playing them games back in the day. This is a blast from the past. Sandbox. So either gaming and even Ape, Coin. Then we could go down. All right. Using visualizations in our analytical process. As mentioned, presentation is not the only purpose of visualization tools. They can seriously help us in our analytical process and can spark curiosity as we work through the data. Fork the above query and make a donut chart with the results. So let's do that. We're going to go down, add a chart. We're going to add a donut chart. We're going to title this OpenSea fees by currency. And our data is going to be, let's just do it in USDC. We'll do currency symbol, and then we'll do total platform fees. So we can see it's ETH, and then all of these little stuffs right here. It's pretty clear that ETH and wrapped ETH is the dominant currency on OpenSea, capturing 99.3% of the fees of the fee revenue in June 2022. But we can still dive in and explore the rest of the data to see if there's anything interesting there. Hide ETH and ETH by clicking on the legend. So we're just open. So we're left with just the other tokens. Notice anything of interest? So let's click that out. Let's click that out. And then we can see all of the other fees, and we can get rid of them by just clicking on them to remove them from the chart. Find some transactions where Gala is the currency. So we'll go here. I'll post this in. So we have these transactions, sale. We have our data. Grab any transaction hash there and look at it in Etherscan. So we'll get the transaction hash, comment, Etherscan. We'll paste it in there. And so we got 50 NFTs. We can look we can look this up in the facts transaction table as well to see how the full transaction is structured. Hint, it's the text.json column. I would just copy that full thing and look at it in a nice structured form using something like this. See the site. You can just use the JSON formatter and paste it in there. Take a look at the JSON and Ethereum and Etherscan side by side. Compare the high level info and maybe look at the logs for where the detail is. So let's actually then go back here. What is it? Fact transactions. Let's see if we could just put fact transactions right here. Oh, so we got to do the hash. So we're going to copy this transaction hash right here. We're going to see what it is in the fact transactions. And it's going to be where block hash, I believe. Oh no, TX hash. Equals this. Two wheres. So here we have this transaction hash in the fact transaction table. And do they have TX JSON? They do not have TX JSON, so let's go into the docs real quick. Ethereum. We're going to go down to the fact transaction table. I don't know what this R is. Let's see if we can see anything. Oh, not in the event logs. So that might be an outdated concept. Let's just try to put it in the event log, actually. So we're going to get rid of this fact transactions. From believe it will be the decoded log. Right here. Oh. I don't think it's going to be the decoded log. Let's see the full one. So that's pretty cool. They have it decoded already. If you wanted to see how it's decoded, this I believe is all the same right here. Learning on the fly, guys. We're learning on the fly. So then that is just all the stuff decoded. So let's take that and go to the JSON format. Paste it in. And then let's check it out on the Etherscan. Go into the Etherscan. Must have missed that part. Oh. Token. All right. Well, it looks like I need to either read on or see what's up. Take a look at the JSON and Ether thing. Compare the high-level info. Maybe take a look at the logs for where the details, the meat of the transaction live. Okay, I believe it is. I see. So look at this one. Well, I can't do that on the thing because it's the same browser. And then we'll go here. So this is the log. Okay, so see how it matches the decoded logs right here? Approval, transfer, approval. So it has the approval stuff right here, at least for the first one. And you can compare it side by side. The nice transaction part, consider the equivalent to the easy tables. All the transaction information is there, like with the fact transaction table, but sometimes we just want a clean cut action. The point is to get used to seeing the full scale of an Ethereum transaction. There's a lot more that we can extract from JSON. It's up to what your analysis requires. We'll get into parsing JSON later. No need to get overwhelmed by this. Whew. Back to SQL. In this case, group by one indicates that the grouping should happen on the first column, which is currency symbol. In a most basic sense, the group squishes the results. So whenever currency symbol equals ETH, those records will be summed up together. Using group by over our prior methods, we are not excluding the record where the currency symbol is not ETH. The fees generated by those sales are included in our records of their own category, but still we can get more granular and begin to look at the patterns. Having. We can filter our aggregated results, but not with where. That will apply to the query. Still, in that the parameters within the where clause impact the result set. When we then use the group by and aggregated functions to compute something over that result set, but what if we wanted to limit those results to exclude outliers or to hone in on a specific brand of volume? We can filter the aggregated results with having. So having is like a where, but for the aggregated results. So let's check this out. Just get rid of some of the other stuff. Move this back over here. Delete this. Paste this in. So this is truncating the block things by the date. For the symbols having when the fees are over 1,000. So you're grouping it by the date and the currency symbol. So these are all the dates that have for each day the currency symbol where the fees are over 1,000. All the total platform fees over here and the USD fees from the easy NFT sales between the month of June from OpenSea, grouped by the date and platform fee, where the fees are over 1,000. Order by the currency symbol or order by the date, and then order by the total USD fees. So it's going to go by the date first, and then it's going to go each day within the day from the top fees in the denomination of the US dollar. Cool. Notice here we use the group by 1, 2. Per above, we should be able to infer this is creating a group based on date, creating a group based on currency within each date. $1,000 was selected fairly arbitrarily, so it's up to the analyst and the purpose behind setting these parameters. Order of operations. Confused about what goes where? Not a problem. There's a lot to keep track of. Of the concepts we learned so far, here are the order of operations for how you should structure your query. Select from where, group by, having, order by. Think about it in clusters. First, we have to get the data and create our result set from select from where. Select, then from, then where. Then we might want to do something to that result set. Transform it in some way, group by or having. Finally, we might want to stay organized, so we order by. We can even use this group by on dates. We want to visualize these sales over time, whether it be day, week, quarter. We can use a special date and time function to truncate the block timestamp to a desired position. Date trunk. We can even use a group by on dates. Say we want to visualize these sales over time, whether it be day, week, quarter. We can use a special date and time function to truncate the block timestamp to a desired position. So right here, they're truncating it as a date instead of just a timestamp. So let's paste this in. Get rid of this visualization. Then we can make either a bar chart or a line chart. Let's try a bar chart. Fees. The x-axis is going to be the date. The y-axis is going to be total platform fees, USD, and then we can group it by the currency symbol. So mostly ETH, but you could see that they're grouped in each one. Another thing that we could use, so if we get rid of ETH, this is all this other stuff. Another one we could use for over time will be a line chart. So we'll name it again to fee chart. Our x-axis is still the date. Our y-axis is the total platform USD. And then we can group it by currency symbol. So we see all of that. If we get rid of ETH and WETH, you can see how the fees go over a period of time. Case statements. We can replace data if we don't like it. No, not in the manipulate the numbers sense. In our fee analyst thus far, we have some 20 plus currencies accounted for less than 1% of the OpenSea fee revenue, and that makes for a really messy outcome. So let's lump all of those into another group by replacing everything that we don't want within currency symbol. Case statements are if conditionals, but we use the keyword when instead of if. When, not where. This can be an easy mix-up in your head early on. The base structure of the case statement is this. Case, declare the start of a statement. When, conditional statement, then outcome. When, conditional statement, then outcome. Else, outcome, end as the alias. The result of a case statement is a column, hence the alias. But what is happening? We are replacing the contents of the column based on some parameters. In our example, we want to keep a select few currencies and every other currency to other. So here we go. We'll paste this in. So what's happening here is they're truncating it by the day and the case. So when the currency symbol is ETH, then it's going to output the currency symbol. When the currency symbol is WETH, so when these three are pop up in the column over here, it's going to just have the regular currency symbol. Else over here is going to pop up in other, ending as a currency symbol, which is going to be the title of our column. And then you're going to have also the other columns as what we had before. Total platform fee and total platform fee USD. Let's get rid of this chart right here. So as you can see, all the other stuff is just other. So if we want to group that into the line chart, We can do the same thing, date, platform fee USD, group by the currency symbols. And even though the other is still down, if we just get rid of the wheat or the wrapped ether and ether, we can see that some days the other is, or the other is more than the USD. So that can help if you just want to see all the other currencies. Notice above, the outcome of when currency symbol equals desired currency is the column currency symbol, while the outcome for else is a string other. In plain terms, we're saying when currency symbol is ETH, wrapped ETH, or USDC, take the value of the column. For everything else, use this string other instead. CTEs, common table expressions. Sometimes we need data in multiple formats. We will need to use it multiple times and in different ways. Or we need to get data from somewhere based on a table elsewhere. We can create a temporary view within our query within a CTE. Think of a CTE as a query in and of itself where the result set is returned. We can see exactly what this result would be if we were to highlight and run the query between the parentheses. If you do, add a limit, or you'll be waiting for a lot of records for a long time. This result can be thought of as a table that exists only while the query is running. Thus, we can use the select from. Thus, we can select from the CTE using whatever name we choose as its alias. In the table below, we'll use OpenC tables. So we'll go through this query in here. So we're doing with, the table's name is going to be OpenC sales, as this table is going to select everything from the Ethereum Core Easy NFT sales chart, where in the month of June, where the block stamp is turned into a date between June 1st and June 30th, 2022, and the platform name is OpenC. So we're doing the same thing. We're doing the same thing, except now from OpenC tables. So we're drawing from this table, which is a narrowed down table of this, and it inputs the same results. Structure. There's a lot of structure and syntax to keep track of, right? CTEs begin with the keyword with. This is only necessary to start the sequence of CTEs. Each subsequent CTE simply follows alias as query. If you watch the video, you'll see how many times I forgot to add the as. It happens. The only other thing to remember is that each is separated by a comma. So you have one table, you put a comma after, you have the other CTE, you put a comma after, until the last one where you don't put a comma after. Notice how we have a final select outside of any CTE. This is a must. This is the last query that will return your ultimate result. CTE example 2, bringing in other data from the prices table. Let's continue with OpenC fee analysis and compare the price of ETH against OpenC fee revenue. So we are going to be comparing two tables. Let's make this a little bit bigger. Actually, I can get rid of this right now. So with the table named prices, as we are selecting the date, the average price, from the Ethereum core fact hourly prices. So the hourly prices gets an hourly price. This averages it out within the day of the month of June. We're grouping it by the date. Open fee is we are using the date. We're getting the platform fees. We are getting the others in USD from the NFT sales table, same date from OpenSea group by one. So we're selecting the date, this from the first table. Oh no, we're selecting this from the second table. We're selecting this from the first table from OpenSea, and then we're gonna left join prices P. So this is the alias for this table right here using date. So let's run this. So we're getting it from this, joining these tables using, which is a snowflake term. So we can see as the average prices, we can see the fees. So to correlate this, let's do line chart. X-axis, date, Y-axis. This is the average price. So this is the average price of ETH right here. And then these are the fees. So kind of correlates as a little bit, but we can see that there's a spike right here in the total platform fees in May. Probably a big mint came out or something like that, but that's about it. We are able to bring the data from these CTEs together in the final query using a join. If you are unfamiliar with how these work, just scroll down. But while we're in the CTE section, one more thing to add. Yes, data from a CTE can be joined in a subsequent CTE. In the above example, we query an aggregated OpenSea fee data in the open fee CTE. However, this could have still been parceled out in two steps, like in the first CTE example, where the first CTE selects the transaction records, OpenSea sales, to code blocks up, and the open fee aggregation could be a subsequent CTE that selects from OpenSea sales instead of from easy NFT sales. So they're saying that they could have done a CTE here and a CTE here, and you could have joined it with this one. Dive deeper. CTE and SQL Geeks for Geeks, common table expressions, how to and when to use them, joins. So we just introduced something wholly new, working with data from multiple sources or tables. How do we combine the disparate results? I don't even know. I guess it's separate. Let's see real quick. Essentially different in kind. Disparate. Oh, fancy. That happens with line 25 and above, where we reference left join X using Y. You may also be used to left join X on A.Y equals B.Y. The keywords using is supported by Snowflake and is a bit more streamlined to use when both columns use the same name or alias. Here we are joining on a common date, but you can take data from a wide variety of columns. Maybe in easy deck swaps, we can join pool name, contract, token name, contract, origin from address, and we can compare the activity from an address across deck swaps and NFT sales. Or if we're working with raw transaction data and need some labels, an analyst can use data from other tables to enhance the outcome. So dim to the dimensions, which are more detailed. There are a number of joins, but the most common one you'll likely use for now is a left join. Left join. In this join, the left table is the one referenced first. In the example below, easy deck swaps is left and dim hourly tokens is right. Declaring the type of join is effectively deciding what data you want to keep. In a left join, we are preserving all rows in the left table, and only joining overlaps from the right table. The below tool does the best job that I have found so far at demonstrating what happens with data from two sources when they are joined together using different methods. So you can see inner join, it'll only, this is it. So for this, since these are only the same names, oh, okay, so name and like. This one right here is only going to join. So it's going to take the whole left table, and if the data matches in the right table, it's going to add it on to the column where it matches. If it's not, it's going to leave an empty column. Or not column, I'm sorry, row. It's going to leave an empty row. Joining on multiple columns. You can join tables using mini columns. An example of this might be date and address. We developed an example on this in the video where it might make sense to track NFT mints and subsequent sales by joining the NFT mint and easy NFT sales on both date and contract address. So let's do this, and then we'll go through this one. So this is saying with the table created as sales, we're getting the date, NFT address, and total price of the sale, where it is current date minus 30, so about a month, and the mints. So you're getting the mints right here, and then we're going to select the M date, so they're getting the mint date because they aliased the mint chart as M for right here, and sales chart as S. So you're getting the mint date, mint address, total mint, and then what you're adding on is the total ETH sale. So as we can see, for the matched NFT addresses right here, these are the mints, and this is the sale for that contract in the day. Some of them have no sales, so that's why their contract is empty. This was written out of a community question and is not refined or polished. The link query goes on to further join contract tables to add some readability to the result. Feel free to fork it and try some analysis of your own with this as a base. On lines 2 to 10, we declare the first CTE that aggregates NFT sales. over the past 30 days from easy NFT sales are second. On lines 11 to 19, queries NFT mints, aggregated total ETH minted per NFT drop in the past 30 days. The final query combines the data from each of those with mints as the left table. Recall from the visual join reference that everything in the table is preserved, while only matching overlaps from the right table and are brought into our final data set. So in plain terms, what we're doing here is taking all of the NFT mints in the past 30 days and by joining on date and NFT address. We are including subsequent secondary market sales for just those addresses in the mint column. Cool. So I'm going to stop here and I'll see you guys